Hi everyone. This is the EI lab of EE533, and in this lab we have built a uh, configurable FIFO which can be used as FIFO and memory. Uh, and this is integrated with CPU and GPU. So this is a unified memory which is common for both CPU and GPU. As you can see in this block diagram, we have used like dual port block RAM, so where one port is shared between CPU and GPU using multiplexing, and the other port is used by the FIFO control unit, FIFO block, where through this port the pay the data from the network is received and sent back to the network. So yeah, this is the top view of our design, and yeah, this is the modifications that we have done for our CPU and GPU, which we built in the previous lab. So if you look at the CPU, we have added extra control signals to the CPU so that both CPU and GPU can handshake, and it can also receive the uh, signals from the control signals from the FIFO, such as data ready, initial and end address of the payload. So with this information, we will be able to process the payload that's there in the FIFO. And yeah, and we have additional control signals to share the data memory between CPU and GPU. Now, Hobo will tell more about the GPU interface and how what are the modifications and enhancements that we have done for the GPU to integrate in this project. Over to you, Hobo.
Thank you very much, Rohit, and thank you for introducing about this system. And now I'm going to share my screen and do some introduction about our GPU part. And as you can see, this is our GPU part. And actually, what I'm showing is like the CPU and GPU top. And inside, we have like to share, as Rohit said, we are going to share this D memory. But now we're inside this code, I'm trying to show the basic part, like this GPU core and the D memory. And we have this kind of basic structure like this. And we also have CPU, GPU, and they combine them into a data processing unit. After that, we put them with a D memory together, and we will use this D memory as our FIFO to get the data to the data processing unit. And as you can see, we have like the extract our parameters, which is being used in the GPU as the thread IDs and also the base address of it. So we thread this word outside to make it can be being accessed to the CPU or outside our FIFO to get just to get the base address of our A and Bs, and we can set a thread ID in it. And uh, the other structure inside this kind of the system is didn't being changed too much. And after that, Yukon will show you how can we use this system like to test the FIFO of it to get the package from network and doing the test bench about our FIFO. And you take control, Yukon.
Okay. Wait, I share my screen. Okay, I will introduce about our FIFO. It's a modification version of the Lab 3 job FIFO, and we don't do jobs and we don't do match. We need to store it in our memory and then it send it out. So this is the whole structure of our FIFO, and this is our top processor that combines our CPU and GPU together. And this is the simulation of that. As you can see, when we send a packet in, uh, it will change to the CPU control mode, and when CPU is doing control, it will proceed. It will executing some datas, and after it executing some datas, it will write the data out. So this is the the after modificate packet. Yeah, so this is the whole test bench, and we will show the implement in our hardware. So firstly, okay, I close it, so we'll do it again. Okay, so firstly, we are going to download the bit file. And we'll do an RKD. And then we write some Perl scripts to monitor the UDP mode packet sent. It's like this. Yeah, this is package send, so it will send two 64 bits data to the node 2, and then our CPU will write it to the register file and then send it back to the memory, and then our FIFO will send the new package out. So it contains some CPU implement, so it will be a little bit l- slower than the pass-through performance. Before we run, we need to listen from the client. Need to listen from the client and listen. Yeah. So when we do the run, it will send two packet, and our target port will receive these two packet. Will receive these two data, and the next we are going to doing the bandwidth test. As I test the bandwidth, the maximum bandwidth is about 129 megabits. Because for now we need to store one packet, and then when we execute the whole packet, we'll send it out. So it will a little bit. So it has some delays. Yeah, so the bandwidth is about 129. And if you increase this bandwidth, you will find some jobs. So this is our whole hardware implement. Okay, thank you very much.